56 degrees. It hit at an angle. If it's longer, well, we have a different number here. It's 2.5. Again, that's the same. We're assuming the same width divided by now a longer thing. That means it was at a stronger angle, or at a whatever it is, a shallower angle. There's more of a horizontal movement. So it did not fall directly overhead. So that's why it stretched. It was like it didn't fall directly overhead. It was at an angle, so it stretched as it landed. So anyway, we take the width divided by the length. That'll give us our number. The inverse sine of that number, 2.5 divided by 3.5 in this case, is 46 degrees. That's a shallower angle, so because it was pushed horizontally. In this case, it was pushed even more because the angle was even lower. And we get to 2.5 divided by 4. The inverse sine of this number gives us 39 because the angle is shallower. And so on. The more stretched it is, the shallower the angle. In theory, it can be stretched, to a certain distance, and you'll even get a zero angle, as if the blood. But that's really not common. Usually, the blood that ends up, let's say, on the wall, will go at 45-degree angle, maybe 10 degree. It's probably not going to be that shallow, but again, it could be, and we can get this out of the inverse sine of the length divided by the width. That'll give you a number that is an angle. So, and this the lowest angle is flung horizontally. That's why it has the most shallow angle. Okay, that's how it's measured. That's how you know the angle of where the blood came from. There are many different kinds of blood spatter that have to be taken, that you have to look at, you have to try to identify. One is the simplest kind is impact spatter. That there's an impact, let's say a club hit a hand, and it bled, and it spread out, and it hit the wall. So that's impact, come from the impact. Gunshot spatter, that can come from a gun, it shoots somebody, and the blood splatters onto the wall. Cast-off spatter, that comes, again, let's say a club hits a head, and the blood gets on the club. So when the club swings back for another blow, it'll cause a certain kind of noticeable spatter on the wall, or on the floor, or wherever it ends up. Arterial spatter, that's if an artery is cut, and these are often fatal situations, but if an artery is cut, the heart will pump blood very powerfully, and it'll spurt very strongly, and you should be able to identify this kind of spatter. There's also spatter that is blown from the mouth or the nose, that when blood is in the mouth, either originating in the mouth or the lungs, and during the breathing it's sprayed out. This also can be identified. And there's also, it's not blood spatter, but it's a void pattern. When you have a spatter and there's a space in the spatter, as if someone was blocking it, something was in there, and we should be able to identify that. Let's take a look at these kinds. Impact spatter. This is, by the way, this picture was done by, I think, shooting a gun into a sponge. It's just, it's not a real crime, but just shows how these things look, or they can look. In an idealized case. So there's forward spatter and back spatter. This means, because you hit the thing, it's not going to go outward, it's going to go in all directions, including back at the attacker. That's just the way the physics works. You send energy into that place, it'll radiate outward in a sphere, not just just to the sides or to the back, which is forward spatter, but even goes back toward the attacker. Often you find this in gunshot wounds. So anyway, a forward spatter that goes away from the attacker, and back spatter that actually gets onto back in the direction of the attacker. These impact spatters are usually for radial, in a radial pattern, as you can see. You start from the middle, and you start from the middle, and it goes outward, and it spreads outward. Notice that you can see how these are elongated. That tells us that there was an angle. It was hit at an angle. But anyway, that is impact spatter. And sometimes back spatter is found on the attacker, and you can actually connect the attacker, a suspect. If you find blood on him from the victim, you can show that this person is the attacker. Okay, when it comes to impact spatter, there are different speeds. They're classified with different speeds. There's low velocity spatter, often like by a fist, or it can even be a very, very low impact by blood just dropping onto the floor. So these are generally like 3 millimeters or more. They're relatively large because there's not much of velocity. So the entire drop, just lands. It doesn't like spray out because of so much violence. It's going at a high speed, so it sprays out. It's not going at high speed. It stays more or less. A large drop of blood would be cohesive, and it'll be from 3 millimeters or so. So you can identify it in that way. There's medium velocity spatter. This can sometimes be by, let's say, a baseball bat or something else. And these drops are smaller, so you can sometimes identify the kind of impact by the size of the blood drops. And then there's high velocity spatter. This comes from gunshots and explosions. Certainly that's high velocity. These are often found less than 1 millimeter, really tiny drops. They are small and they don't travel far, but it really depends on the situation. You may actually be carried by the gunshot, or sometimes bits of bone with blood on them could spray out, and these bits of bone carry blood elsewhere. So generally by themselves they don't travel far because they're very small. So you can sometimes identify what happened. You see a dead body with blood. You can say, "Oh, this guy must have been hit by a bat. This guy, this person was stabbed, and the blood just dropped down, or something like that." Or you can even say it must have been a gunshot. But usually there's other evidence that there was a gunshot or an explosion. So we would like to know the origin of the blood, because again, we're trying to reconstruct the crime. We want to know where the victim was and possibly where the attacker was. So we want to find the origin of the blood. So what we do, we find, blood, again, it's going to end up on a flat surface. Again, it doesn't have to, but usually it's a wall or a floor. I mean, yes, it can end up on, let's say, a book, or not a book, or let's say a pen, which is not a flat surface, but very often it ends up on a flat surface, so we can use that. Remember here, here's the example. It's a diagram of what might happen. Maybe we should blow this up a little bit. Okay, suppose you have these blood drops. What they would do is they'd say, okay, I know the direction. Let's say you have some satellite over there, so you know satellite over here, so you know the satellite over here, so you know the direction that it was going. So you trace that back to a certain place. So you take all these blood drops and the blood, you use the blood spatter of these blood drops, and you find that basically where the origin was. So we can do that. That's the first thing we do. Where on the wall, let's say, the impact was. Now, first, we don't assume the person was hanging onto the wall. So, but as far as height is concerned, we can find out how high the attack or the source of the blood was. So again, these things form an area. So that just tells them, like, let's say how high he was, or where forward and back he was. But how far away from the wall was he? So for this, we usually use the string method, and it tells us the volume of origin, like more or less where the person was. People occupy a volume, so it's like a more volume of origin, but it's called the area of origin for whatever reason. So again, this thing will tell you, let's say, how high it was. However, we can also remember that. Let's get a little. Remember that we can tell by comparing the height to the length.